Hi guys, hi maths, trig expressions, related angles and exact values. We're going to have a look at calculating the cos of -45 degrees here. So again, we'll set up the cast diagram, so ASTC, so we've got the first, second, third and fourth quadrants here. Now it's the cos of -45 degrees, so we're actually going to, instead of going for in the anti-clockwise direction for -45, we need to go in the clockwise direction. So we're going back into the fourth quadrant here. So in terms of thinking about the cosine graph, this is what would be happening. We'd be counting back 45 degrees. So if we have a look, this height is the same as the height we'd have at 360 minus 45. So cosine's positive, and we've done 360 minus 45 here, we're counting back 45 degrees. So the cos of -45 degrees is equal to the cos of 45 degrees. And again, we can see this from the graph here. If we count along 45, we'll get to a height of 1 over root 2. If we count back 45 degrees and see the height of the graph, that would also be a height of 1 over root 2. So the cosine of 45 degrees from our exact value knowledge is 1 over root 2. Next question, tan of 495 degrees. So in this one, we've got an angle over 360, so we'll loop round once for 360 degrees, then another 90, which will take us to 450, then another 45, which takes us to 495 degrees in total. So the tan of 495 is just the same as the tan of 135, because we've got 90 and 45 to get there. 90 add 45 is 135. If we're looking at the tan graph to see if that makes sense, well, there is 135 degrees, and there's 495 degrees, and it is at the same height. It doesn't look on my diagram because I've not drawn it as well as I should have, but it would be at the same height. So is tan positive in this quadrant? No, it's not. Only sine is positive. And this is the quadrant where we use 180 minus to calculate it. So tan of 135 is the same as the negative tan of 45, because I need to count back 45 degrees from the x-axis to get to the line here. So the tan of 135 is the same as a negative tan of 45, which is -1. Right, one more question. Given that the cosine of angle A equals 2/3, find the exact values of the sine of A and the tangent of A. So cosine is adjacent over hypotenuse, so the adjacent side, so I've sketched a right angle triangle. The adjacent side will be 2, the hypotenuse will be 3. So I've used a bit of Pythagoras to find out the opposite side, the missing side here. So 3 squared minus 2 squared, hypotenuse squared minus the adjacent side squared. So that's 5, and square rooted, the height will be root 5. Now once I've done that, the cosine of angle A, as we know from the question, is 2/3. The sine of angle A is the opposite side divided by the hypotenuse, which is root 5 over 3. And the tan of angle A is the opposite side divided by the adjacent, which is root 5 over 2. And that is that.